This is integration packet number 17, problem number 8. I have gone ahead and put some color into this problem, and with the green highlighted under the curve, as you know, the area above the x-axis is a positive area, and area below the x-axis is considered negative area. So with us trying to find net distance, that is just integrating the whole function from the beginning point to the end point, using those limits, which in our case are 0 to 3 pi. So if you just integrate that, it will take into account the positive and negatives part and give you the end result of the net distance. Okay? But on B, it's asking for the particle's total distance. Now, so for example, if you were running around a track and you ran clockwise around the track for a mile, okay, that net and total distance would be if we consider clockwise positive, that would be a net and total distance of a mile. Now, if you ran a half a mile clockwise and a half a mile counterclockwise, then the net distance would actually be 0, because you would end up at the same spot that you got, and the positive area going counterclockwise would negate the negative area that going counterclockwise. So, but your total distance would still be a mile. Your net would be 0, your total would be 1 mile. Okay? So to allow for that, we can do two things, and I'm going to do the harder one first. For total, you need to compensate and account for when the function has negative area that is accumulating. So the first green section there, that area is positive, so I can just go 0 to pi. And then I'm going to just write v of t for the sake of space in this video. Okay. And then the second section, where we go from pi to 2 pi, that's negative area. So if I subtract off that area, okay, this value in here will create a negative number, and a negative, subtracting a negative will lead to a positive. So, and then the third section, we would just have to add on from 2 pi to 3 pi of our velocity. When we integrate velocity, we get distance. Okay, so whatever number that comes out to be, and I actually believe it is 28.27359. Okay. Now, a simpler way to do that, and assuming that you actually have a problem like this where you need a calculator to solve it, you could just put in your calculator going from 0 to 3 pi, the absolute value of the velocity dt. All right, and in order to find absolute value, if you go to Math, Num, and number 1, which is ABS, you can create an absolute value. So again, on your calculator, that is Math, go to the right to Num, and then ABS stands for absolute value.